In this video, we're going to look at doing some basic operations with algebraic terms. Now, when we write an algebraic term, we usually just leave out the multiplication sign. So any numbers, the coefficients, are written at the front, and all the letters, known as pronumerals, should be written in alphabetical order. So let's see what this means. So 4 times A. It's 4 lots of A, and I just write that as 4A. So remember, when you see 4A, it's not 4 plus A, it's 4 times A. And 4 is our coefficient, and A we know as our pronumeral. 1 times B is just B, and we've just got one lot of B. So I don't need to write the 1 in front of my pronumeral B. 3 times D times C, I write that as 3CD. Preferable to DC. I keep my pronumerals in alphabetical order. And 6 times E times E. Our last example here, I'm not going to write that as 6EE. I'm going to write that as 6E to the power of 2, or 6E squared. So let's look at simplifying some terms. Now, if I've got x plus x plus x plus x plus x. How many lots of x have? I've got 5 lots of x. That's 5 times x. Now let's have a look if I've got x times x times x times x times x. This time I've got 5 x's multiplied together, so that's x to the power of 5. Similarly, x times x would be x squared, x times x times x, x cubed, and 4 lots of x multiplied together would be x to the power of 4. So remember, our indices or our powers tell me how many of the base, which in this case is x, are multiplied together. So let's look at simplifying some expressions when they're multiplied together. 3p times 2p. So if I expand that out, that's 3 times p times 2 times p. Remember, we can rearrange our order. So we'll multiply our numerals first. So 3 times 2 is 6, and then p times p is p squared. So we end up with 6p squared. Let's look at another one. I've got q squared by q to the power of 3. So if you remember your index laws, I add the power. So let's look at how this works if we expand it out. Q squared is q times q, multiplied by 3 more lots of q. So I have q to the power of 5. So remember, back to our index laws, when I have the same base multiplied together, I add the indices, or add the powers. Let's look at this one here. I've got 2 times p multiplied by 2 times t. So I can think of the whole thing as multiplied by itself, so I can put the whole thing in brackets, so it becomes 2t squared, or to the power of 2. Or I could also just write it as 2 times 2 is 4, and t times t is t squared. Now please note the difference. Here I've got brackets, so everything, the 2 and the t, are squared. But here, the squared only applies to the t, not to the 4. So now what happens when we're adding and subtracting? You can only add or subtract like terms. So we need to know what are like terms. Now, like terms are where the pronumerals, or the letters, are exactly the same except for their order. So 3x, 5x, and a half x are all like terms because the letter x, the pronumeral, is the same in all of those. But here, 3x and 3x squared are not like terms. Yes, they both have an x in, but don't forget, 3x squared is 3 times x times x. So therefore, it's not the same as 3x. Doesn't matter about the coefficients, that would be the same even if that was a different value other than 3. 3xy and 5yx are like terms because they both got one x and one y multiplied together. Remember, xy is the same as, x times y is the same as y times x. So yes, they are like terms. The order doesn't matter as long as the pronumerals are the same. Now this one, I've got 3x squared y and 5xy squared. They are not like terms. The squared here means I've got two lots of x multiplied together, and this squared is next to the y, so I've got two lots of y. So 3x squared y is 3xxy, 5xy squared is 5xyy. So you can see the pronumerals are not the same, so they are not like terms. So let's put that in practice. Let's say I've got 5 lots of x and I'm adding 3 lots of x. So if you can see what I've got, my terms are like terms because both of them contain a single x. So I just, as I say, 5 lots of x plus 3 lots of x gives me 8 lots of x. Okay, nice and simple. If I had 3 lots of A and I added 4 lots of A and then I took away 2 lots of A, check that they're all like terms. So I've got 3 plus 4 minus 2 lots of A. So 3 plus 4 is 7 minus 2, leaves me with 5 lots of A. What happens though when we've got a thing where not all the terms are like terms? Let's say I've got 3 lots of A plus 7 plus 6 times A, or 6 lots of A, minus 2. So here, not each one of my terms has got the pronumeral A. So what I'm going to do is I'm going to do something called collecting like terms. I'm going to regroup it. Now the thing to remember is the fact that the sign before the term belongs to that term. So that plus 7 plus 6A minus 2. So now that I'm looking at what I can do, I'm going to rewrite this expression grouping my like terms, and I'm going to remember to take the sign that belongs with each one. So 3A, my like terms with 3A is my plus 6A, so 3A plus 6 lots of A plus 7 minus 2. Now that I've got my terms grouped, I can look at each section and work that part together. So there's my first set of liked terms, and so that becomes 3A plus 6A becomes 9 lots of A. And here's my second set, plus 7 minus 2. So 7 minus 2 is 5. So 9A plus 5. Right, let's look at adding like terms with a slightly more complicated example. So in this case here, I've got 7x squared plus 2 minus 3x squared plus 5x minus 6. I'm going to do the same thing. First of all, I'm going to look at grouping my like terms. So my first term is 7x squared. So I'm looking for any terms that have the same pronumerals as x squared. And I can see it over here, minus 3x squared. Please note that I said minus 3x squared because that negative sign belongs to this term here. So my first line of working is going to look like 7x squared minus 3x squared. Then I'm looking at my next term here is plus 5x. There's no other terms that just have an x in, so I'm just going to write that as it is, plus 5x. And now I'm left with plus 2 minus 6. So if I'm doing each section, then my 7x squared minus 3x squared becomes 7 minus 3, 4x squared. So think of it, I've got 7 lots of x squared. I'm taking away 3 lots of x squared, so I'm left with 4x squared. My 5x remains as it is, so 4x squared plus 5x. And then I've got plus 2 minus 6. So if I look at that, I'm starting over here. If I think of my number line, I'm starting over here at 2. There's 0. I'm taking away 6. So I'm going to end up over at negative 4. So the last part becomes minus 4. So plus 2 minus 6 minus 4. That's as far as I can simplify that. I've got 4x squared, there's no other like terms with that, plus 5x minus 4.